My name's Mrs. Chiverton and I am one of the science directors, and I'm going to continue with my series of lessons on quantitative chemistry. This is lesson 3 in the series. This is intended only for students who are studying higher combined or higher triple content. If you are doing the foundation papers, you do not need to do this lesson. So before we start, can we just make sure we've got all of the resources that we need? So switch off any notifications on the devices that you are using so you're not interrupted. Can you make sure you've got some paper, a pen, pencil and ruler, or your exercise book to record your calculations and any other information from the PowerPoints? You are going to need a calculator. If you don't have access to a calculator, then both phones and computers will have a calculator function on them, and you can always pause the video to use that function before restarting the video again. In addition, you'll also find your Outward Student Planner handy with a periodic table in, which appears on page 147. So, just a bit of a reminder and a practice of skills from a previous session. First of all, I want you to record how we calculate the relative formula mass of a compound, and then I'd like to apply that and calculate the relative formula mass of the compounds that I've listed on the slide here. And if you could please do that in 2 minutes. So calculating the relative formula mass is often the starting point in much more complex calculations. So hopefully you've managed to do all of these. So what we do is we start with the correct formula for that compound, and then we add the atomic mass of each atom in the compound. Remember, we can get the atomic masses from our periodic table. It's the larger of the two numbers in the boxes. The massive number is the mass number. So in terms of those chemicals that I asked you to do, so water has a molecular mass of 18, carbon dioxide it's 44, calcium chloride is 111, sodium hydroxide comes out as 40, calcium carbonate is 100, and calcium hydroxide is 74. Remember, if there are subscript numbers, it only refers to the atom previous to it. And if things are in brackets, you have to times everything in the bracket by that subscript number. So today we're going to move on and we're going to do some more complex quantitative chemistry, calculating moles. So in your exercise book, please can you put the title Calculating Moles? Make sure you've underlined it neatly and you're ready to move on. So In today's lesson, our challenge is to be able to describe what a mole of a substance is, and our aspire is to be able to calculate the number of moles in any given mass of a substance. Don't panic, it's actually more straightforward than it sounds. So we're going to concentrate on water for now. The relative formula mass of water is 18, as you've just worked out. And we get that by adding 1 and 1, which is the mass of each hydrogen atom, plus 16, which is the mass of every oxygen atom, and that gives us our total of 18. If I had 18 grams of water, which is the mass of 18 millilitres of water in a beaker, how many water particles do you think would be in that beaker? Write down a number. I'll give you 30 seconds to think of a reasonable number. So in 18 grams of water, 18 millilitres of water in a beaker, how many water particles did you think there would be in that beaker? Well, hopefully you may have got an answer, but I'd be very surprised if any of you managed to get the fact that there would be this many number of particles in there. 602 and then an awful lot of zeros. Okay, now we can change that number into a more manageable or usable number by transferring it into standard form. Okay, so when we convert it into standard form, we take the numbers that we've actually got that aren't zeros, all right, but the digit number always has to be between 1 and 10. So we would have to convert that 602 to a number between 1 and 10. So we come up with 6.02. And then we multiply it by how many times we would have to multiply the number by 10 to get to the original number. So we just count the number of digits that there are after that 6. And if we count those up, there's actually 23 numbers after that 6. So it's 6.02 times 10 to the power of 23. And somebody actually calculated this quite some time ago. So 6.02 times 10 to the 23. This is a mole. It's a measure of how much of a substance there is in science. And the units for moles is mol. So scientists use the mole as a measure of chemical amounts because the number of particles are just too big to work with. So 1 mole of any substance is always the same number of particles. It's always 6.02 times 10 to the 23 particles in that mole. So we need to learn this number. It's a really, really important number, but we also need to know that that is represented by a mole. And it has the name of the scientist who originally suggested it, Avogadro. So Avogadro's constant is 6.02 times 10 to the 23. And that's often a nice easy mark on an exam question. Now moving forward, the mass of 1 mole of any atom or any compound is equal to its formula mass in grams. So for example, if I had 1 mole of carbon-12 atoms, it would weigh 12 grams. If I had 1 mole of hydrogen gas, it would weigh 2 grams. I simply add up, find the formula mass, 1 plus 1 is 2 for the hydrogen, and then I convert it into grams. A mole of carbon dioxide would weigh 44 grams, so that would be 12 for the carbon and 2 lots of 16 for the oxygen, gives me a formula mass of 44. Convert it into grams, that is 1 mole of carbon dioxide. So you have got 1 minute 30 seconds that in your exercise book or on your paper, please record what a mole is, what Avogadro's constant is, and how you work out the mass of 1 mole. Okay, grab a different coloured pen so you can self-assess your work. So what we should have had is a mole is a measure of the amount of substance in science. The unit for moles is mole, and 1 mole always contains the same number of particles. If you missed any of those, add them in a different colour. Avogadro's constant is 6.02 times 10 to the power of 23. Make sure that 23 is subscript up in the air. And how do you work out the mass of a mole? The mass of 1 mole of any atom or compound is equal to its formula mass in grams. So please add and amend anything that you think you have missed on those definitions. And it's really important that you learn these things because these are some of the fundamental questions that you could be asked on your chemistry papers. Now, what we're going to do is we're going to move on and we are going to look at how we can calculate different quantities using that relationship. So when we are calculating moles, we first of all need to clearly work out the molecular mass of the substance or the atomic mass if it's an element. So for example, with carbon dioxide there, we do 12 plus 16 plus 16 equals 44. And we signpost it, we say that that is the MR. We then simply convert that value into grams. So the mass of 1 mole of carbon dioxide is 44 grams. Easy and straightforward. It helps in exams because if you do make an error, then it's very clear where, and you might still get marks if this is a longer calculation or first step in a more complex calculation. Okay, so let's put this into practice. What I'd like you to do is to work out what the mass of 1 mole of each of these substances are. I've given you the correct chemical formula. Start off with the nice easy ones and work your way up to the harder ones. What I will say is work out the molecular mass very clearly first and then add G on at the end to convert it into grams. And I'm going to give you 2 minutes to complete that. Okay, that should have been nice and straightforward. Let's just check those answers on before we move on. So lithium, the atomic mass of lithium is 7, so 1 mole is worth 7 grams. Sodium chloride, the molecular mass is 23 plus 35.5, comes out as 58.5, so 1 mole weighs 58.5 grams. For O2, we just have to remember what that 2 stands for. So it's 2 lots of 16 mixed 32, and we convert it into grams, so 1 mole has a mass of 32 grams. For iron oxide, Fe2O3, we've got 56 times 2 for the iron, 16 times 3 for the oxygen, comes out as 160. We convert it into grams, so 1 mole is 160 grams. And then the final challenging one, we have got 6 lots of 12 for all of those carbon atoms, 12 lots of 1 for the hydrogens, and 6 lots of 16 for the oxygen. It gives us a total molecular mass of 180, and then we convert that to grams for 1 mole of it. So well done if you got all of those correct. So we are able now to describe what a mole of a substance is. And what we're then going to be able to do is look at our Aspire outcome to actually calculate the number of moles in any given mass of a substance. So this is an incredibly important equation, and you absolutely need to know this. The mass is equal to the formula mass multiplied by the number of moles. All right, I remember it as mass equals Mr. Mole, but you can remember however you want to, so long as you get it in the correct order. So the mass is equal to the formula mass multiplied by the number of moles. Formula mass, of course, is MR, as in Mr. So if we know how many moles of a substance we have, we can use this and its formula mass to calculate the mass in grams of a substance, and it must always be in grams. So here's an example. What is the mass of 0.5 moles of water? So we start off with the formula mass of water. So it's 1 times 2 for the hydrogens plus 16. So we end up with our formula mass of 18. And we clearly show how we've worked that out unless they give us it in the question. We then put in the numbers that we know. The mass is the formula mass 18, which we've just calculated, and 0.5, which is the number of moles that we've got from the question. Using a calculator, we then work out that the mass is 9, and we know that units is always in grams. So remember to always substitute in first in your equations and then rearrange if you need to, because you're more likely to get it wrong. In this case, we didn't need to rearrange. So again, a little bit of practice for you. 3 questions to do. So remember, you will need to work out the formula mass or look up the atomic mass of the chemical first. You've got the number of moles in the question, so it's very straightforward arithmetic. Well done. Hopefully you've managed to get through those. So we're just going to quickly self-assess these. So the first one, 0.25 moles of calcium. So we work out the formula mass, which was 40, the atomic mass of calcium. We multiply it by the 0.25 from the question, and we should have come out with 10 grams. For 0.2 moles of sodium hydroxide, again, we work out clearly the formula mass first of the sodium hydroxide. We then use that value times by the 0.2 that's come from the question, and it comes out as 8 grams. But you must show that you have worked out your MR first. If you do it separately like this and you've made a mistake for some reason in the molecular mass, then you could still get the final mark for knowing that you changed the molecular mass by the number of moles to get the mass. And then the final one, 0.75 moles of copper sulfate. So again, clearly work out the molecular mass of the copper sulfate, then multiply that value by 0.75 and you should get 119.6 grams. The other thing is, if you're rounding any numbers, don't do it till the very last stage in your calculations. So that's the easy way of doing it because it's a very simple sum. But what if we have to find out the number of moles instead of the mass? So this time you will have to rearrange the equation. The simplest way to do it is to write out the equation as it is, fill in any numbers that you already know, and then make the amount that you want to calculate the subject of the equation by dividing out on both sides to leave that value on its own. And then you do your final calculation. So I'll take you through an example of that. Okay. Substituting in first, then rearrange if you need to because you're less likely to get it wrong. So I'm going to start off again and I'm going to keep that equation up because the more you read it, the more you're likely to remember it. The mass equals the formula mass multiplied by the number of moles. So the question asks, how many moles are there in 27 grams of water? So my first stage is to work out the formula mass of water, and I'm going to show my working out really clearly because again, if I make a mistake at this stage, then I can still get credit for that answer later on in the calculation. I write out my equation, mass equals formula mass times by the number of moles. And then what I do is I substitute in the numbers that I already know. So 27 grams, that goes into this point because that's the mass and we got that from the question. The formula mass I've just worked out, so I put that in and my 18 there. So now I have an equation that says 27 grams equals 18 times the number of moles. But I simply want the number of moles, not 18 times the number of moles. So just like you would in maths, to simplify it down, I'm going to divide both sides by 18. 18 divided by 18 comes out as 1, so that leaves us the number of moles on that side. And then we do 27 divided by 18 on the other to find out the final mass of, the number of moles of that mass of water. So it comes out as 1.5 moles. In other words, 1.5 mole. So, using that information, can you please apply that to have a go at these 4 questions? Remember, it is important that you show you're working out and it's very methodical and step by step every single time. Now there are 4 questions. I'm going to give you 2 minutes to work your way through those questions. If you need longer, just pause the video and that will give you a chance to do them. In each case, you're working out the number of moles from a given mass. Okay, let's check your answers. So in the first one, 66 grams equals 12 times moles. We divide 66 by 12 and we come out with 5.5 moles. Number 2, working out the molecular mass is 44. So 22 grams equals 44 times the moles. Divide both sides by 44. We end up with 22 over 44 equals the number of moles, which comes out as 0.5 moles. For number 3, again working out the molecular mass, we end up with a molecular mass of 40. So 80 equals 40 times the moles. Divide both sides by 40. We end up with 80 over 40 equals the moles. So that comes out as 2 mole. And finally, 2.4 grams equals 12 times by the number of moles. So 2.4 divided by 12 is the number of moles. So we come out as 0.2 moles. Hopefully you got all of those correct. If you didn't, go back, watch the video again in terms of how to calculate those things and have another go. So, mR times moles equals mass. It's the same equation, we've just flipped which side mass and mR and moles are. You can use it either way, it doesn't matter, so long as you get the three things in the right places. So they won't tell you it's an exam and you absolutely must learn it. Okay. This is one of those places where they will ask you to calculate things, and it's very, very common to give your answer to 3 significant figures. All right, it's a place where they can add extra marks in math for the maths, so don't miss out on those marks. Don't forget to show all the stages of you working out. So I'm going to give you 4 minutes to practice working out the number of moles. I've given you the name and the formula of the compound. You will need to work out the formula mass, and I've given you the amount that you've got, and then you need to use those 2 values to work out how many moles of a substance that you actually have. So you've got 4 minutes to get plenty of practice in. Okay, so let's just check those. So these are the formula masses of each of those compounds that were listed in the table. So check through and make sure that you have got those values correct. Make sure you've added the correct number of each type of atom according to the little subscript numbers if there are any there. Okay, and we're going to look at have you correctly calculated the number of moles. So in this situation, we have substituted them into the equation and then simplified the equation in every case. Now, please note where there was an incredibly long number of decimal places after on your calculator, what I've done is I've written that number down and then I have simplified it to the 3 significant figures that were asked for in the question. So please make sure that you actually do that. Otherwise, if you've made a mistake earlier on, you may not get the mark for the 3 significant figures. So make sure you write the whole long number down and then round it in order to get every mark that is available to you. And don't forget that if you only end up with 2 digits, then the third digit can be a 0 if it's 3 significant figures. So check your answers off and hopefully you've got all of those right as well. So we can now also calculate the number of moles in any given mass of a substance. Now our plenary is to think about what questions would look like using moles in an exam. So we're going to look at an exam. So this is a typical exam question. A student burnt some ethanol. The table shows the mass of the spirit burner before the ethanol was burnt and after the ethanol was burnt. And we have those 2 values written down. And it's the mass of the spirit burner and the ethanol, and then the spirit burner after the ethanol has been burnt. It asks you to calculate the number of moles of ethanol that were burnt. So calculating, we know that that is going to be using some kind of formula to work something out, and we must show all of our working out. We're talking about a chemical reaction that's happening here, so we need to refer back to that table of before and after to work out how much ethanol was actually burnt. So what is the difference between the start and the end? We've got a formula there for the ethanol, so we can work out the molecular mass of that compound given the numbers that have been provided and the formula that is there in the question. And because it's the number of moles, the equation that we are going to use is mass equals mR times moles. We're going to substitute in the values that we have, and we're going to rearrange and solve it. So you've got 3 minutes, as it's a 3-mark question, to try and complete that to the best of your ability, showing all of your stages of your working out. Okay, so look at the answers on that one. So your first step was to actually work out how much ethanol had been burnt, and that's a simple takeaway sum. 72.8 minus 72.1 it comes out as 0.7 grams. You then needed to work out the formula mass of the ethanol. So 2 lots of 12, 6 lots of 1 and a 16 comes out as 46. And then we write down our formula, we substitute in what we know, we simplify things down, and your final answer should have been 0.015 moles. So that's the new learning for today. This is a summary of today's lesson. So 1 mole of any substance always contains the same number of particles, which is 6.02 times 10 to the power of 23. This is Avogadro's constant. The mass of 1 mole of any atom or compound is equal to its formula mass in grams. We have that magic formula, mass equals formula mass times number of moles. And when we're wanting to work out the number of moles, we write out the equation, fill in the numbers we already know, make the amount that we want to calculate the subject of the equation, and then we calculate it. If you're missing any of these notes, please add them to your summary. Pause the video while you do so. If you've got all of those notes down, you can move on to the final step in this lesson, which is completing the Google quiz. Again, you'll be expected to do some calculations, but most of the quiz is multiple choice and therefore will be marked automatically, and there will be feedback on any that you got wrong to show you what you should have done in order to gain full marks. Good luck with the quiz.